In this video, let's do some examples of simplifying radicals that contain numerical coefficients and variable expressions. On the left, we need to simplify the square root of 8x to the third. For the coefficient 8, the biggest perfect square that will evenly divide 8 is 4. So we'll rewrite 8 as 4 times 2. For the variable portion x cubed, the biggest perfect square that will evenly divide x cubed is x squared. So we'll rewrite x cubed as x squared times x. So that gives us the square root of 4 times 2 times x squared times x, which is the same thing as the square root of 4 times the square root of 2 times the square root of x squared times the square root of x. The square root of 4 is 2 because 2 times 2 is 4. The square root of 2 is fully simplified, so it remains the square root of 2. The square root of x squared is x because x times x gives us x squared. Because the variable x underneath the square root symbol only has an exponent of 1, it's already fully simplified, so it remains the square root of x. Now let's group together all of the factors that are not underneath the square root symbol and the factors that are underneath the square root symbol. 2 times x is outside the square root symbol, and we have a 2 times x underneath the square root symbol. So the fully simplified form of the square root of 8x cubed is 2x times the square root of 2x. Again, because all variables represent positive numbers as given to us in our instructions, no absolute value bars are needed outside of the square root symbol. Now let's look at the example over on the right. Let's simplify the square root of 128 a to the fifth. The largest perfect square that will evenly divide 128 is 64. So we'll rewrite 128 as 64 times 2. The largest variable expression that will evenly divide a to the fifth is a to the fourth. So we'll rewrite a to the fifth as a to the fourth times a. So that gives us the square root of 64 times 2 times a to the fourth times a. Using the multiplication property of radicals, that gives us the square root of 64 times the square root of 2 times the square root of a to the fourth times the square root of a. The square root of 64 is 8. That's multiplied by the square root of 2, which is already a fully simplified radical. That's multiplied by the square root of a to the fourth, which is a squared, because a squared times a squared gives us a to the fourth, and that's multiplied by the square root of a. The square root of a is a fully simplified radical because the exponent on the variable a is a 1. And for us to simplify it further, it would need to be at least a 2. Combining the factors of 8 and a squared outside of the radical symbol gives us 8a squared, and combining the factors inside the radical symbols, 2 and a, gives us the square root of 2a. So the final simplified form of square root of 128 a to the fifth is 8a squared times the square root of 2a. And again, no absolute value bars are needed because all variables represent positive numbers. Now let's simplify some cube root expressions. On the left, we need to simplify the cube root of 81 xy cubed. We will rewrite 81 as 27 times 3 because 27 is the biggest perfect cube that will evenly divide 81. There's no need to rewrite the factor of x because the cube root of x is already fully simplified. And there's no need to rewrite y cubed because y cubed is a perfect cube. It's y times y times y. So now we have the cube root of 27 times 3 times x times y cubed. Using the multiplication property of radicals, that gives us the cube root of 27 times the cube root of 3 times the cube root of x times the cube root of y to the third. The cube root of 27 is 3 because 3 times 3 times 3 is 27. The cube root of 3 is already fully simplified. The cube root of x is already fully simplified. And the cube root of y cubed is y because y times y times y gives us y cubed. Putting together our factors outside of the cube root symbol gives us 3y, and putting together our factors inside the cube root symbol gives us the cube root of 3x. Let's look at the example on the right. Here we need to simplify the cube root of negative 24x to the fifth. The biggest perfect cube that will evenly divide negative 24 is negative 8. Remember, negative 8 is a perfect cube because it is negative 2 times negative 2 times negative 2. And there's a reason that I let the perfect cube be the negative value here. We'll see why in just a little bit. And then we'll rewrite x to the fifth as x cubed times x squared, because x cubed is the biggest perfect cube that will evenly divide x to the fifth. So that gives us the cube root of negative 8 times 3 times x to the third times x squared. Using the multiplication property of radicals, that gives us the cube root of negative 8 times the cube root of 3 times the cube root of x to the third times the cube root of x squared. The cube root of negative 8 is negative 2. The cube root of 3 is already fully simplified. The cube root of x to the third is x, because x times x times x is x to the third. And the cube root of x squared is already fully simplified. And that gives us negative 2x times the cube root of 3x squared. Now let's talk about why I decided to rewrite negative 24 as negative 8 times 3 rather than 8 times negative 3. 8 times negative 3 might have worked as well, because 8 times negative 3 is still negative 24. However, rewriting negative 24 as 8 times negative 3 would have given us a negative on the inside of our radical. That would have been incorrect, because remember, a radical is not considered fully simplified if there's a negative underneath the radical symbol. That's why I made the decision to represent negative 24 as negative 8 times 3. Because I knew when we simplified the cube root of negative 8, that would give us negative 2, and the negative would then end up on the outside of the radical rather than on the inside. So a good rule of thumb is that whenever we're simplifying a cube root that contains a negative coefficient, always let the negative go with the factor that is the perfect cube when we rewrite it. Doing that will ensure that the negative shows up outside of the radical symbol rather than underneath it.